Wait a moment. And now I think we can start our trainings. And the first lesson of our today's training, it is the experiment about the VXLAN. And in this experiment, we have three sub-experiments. The first one, it will be the static VXLAN tunnels, and we will establish the VXLAN tunnels by manually. And then the second one, it will be the centralized VXLAN gateways, and we will use the VBDF to meet the requirement of the communication between different VXLAN segments. And the last one, and the most difficult ones, it will be the VXLAN distributed gateway. And for this part, we will use the VXLAN tunnels, and we will use the BGP, USB, and you will find that it is more difficulties for you to understand. So, so now in the first experiment, let's look at what we need to do. And in this experiment, we will use one. Wait a moment. I need to. Okay. In this experiment, we need to use the VXLAN tunnels to finish a level 2 communications through the underlay. It means we need to use the VXLAN tunnels and to let PC1 and PC2 they can communication with each other, although they are connected into different switches. And you will find that these topologies, we have 5 switches, the board switch, edge switch, and two edge switch and two access switch. The access switch, its function is to finish the requirement of the VLAN access, and then the traffic from the PC1 sent to access. Access will encapsulate it with the VLAN ID sent to edge, and then edge will function as the V type. So we'll configure the VP functions, and the VP functions will transmit will convert the VLAN ID to VXLAN VNIs, and then between edge switch 1 and edge switch 2 will establish the VXLAN tunnels so PC1 and PC2 can communicate with each other. And you will find that we have a board switch. So this board switch is function as the underlays. And actually, edge1, edge2, and border, they need to function as the underlays. And we choose the OSPF protocols to function as the IGP protocol to meet the requirement of the connectivities of the underlays. And we have already designed the IP address between the border and the edges, and we will use the VLAN if interface to configure the interconnected IP address. So now let's look at what we will do in this experiment. And the first thing is we need to configure the basic connectivity configurations. So it includes we need to configure the VLAN between the switches. All right, just because we use the VLAN if to meet the requirement, and then we need to configure the interface. It means the VLAN if. After it, we need to configure the OSPF. All right, but now we have the experiment environment, and the environment is empty environment. So we need to finish everything now. Okay, now let's look at what is the first things. The first things is we need to configure the VLAN on the edge 1, and we need to configure the VLAN if on edge 1. And we have already, and also we need to configure the interface loopback 0. This interface we configure its IP address, and this IP address will be used as the OSPF route ID, and later in the distribute VXLAN gateways, this address will also be used as the BGP European route IDs. Okay, now let's finish. Let's start our configuration. Wait a moment. Now let's open the terminal, the first device we need to configure is the edge one, and we need to create the VLAN. All right, we need to create the VLAN, and we need to configure the VLAN if and loopback 0 on this device. And wait a moment, I think we don't need to configure it one by one. The first thing is we need to configure the VLAN. All right, the VLAN, this VLAN is used to establish the VLAN if with the with the borders, and another VLAN is used to bind with the BD. All right. So first we need to configure two VLANs, and the first VLAN we need to configure the VLAN 12 and 100, and then we need to configure the interface, the physical interface between edge one and the borders, and we need to configure this interface, configure it to the trunk port. We need to configure the trunk port, and then we need to allow pass the VLAN 12. All right, and then we need to configure two interfaces. The first interface is the VLAN if, and another one is loopback zeros. This interface is used to connect to communication with border, and this interface is used to function as a router ID. And for the border and for the H2 switches, we need to configure the similar things. All right, then we need to configure the H2. You'll find that we need to configure for the border. Let's configure the border. We need to create the VLAN, and we need to create the physical interface and VLAN if and interface loopback 0. Okay, I have already configured it, so I can just copy the script into this device. And it is both the device. Now you can find that we create the VLAN. The two VLAN is used to communication with edge switches. So we configure the physical interface, we configure the VLAN if, and we configure loopback zeros. And then it is the edge 2, this switch. We need to finish the basic config. It is edge 2 switch. Wait a moment, for the edge 2, we need to create a VLAN that is used to communication with border, and we need to create the VLAN that is used to access the to finish the access function of the terminals, and we need to configure physical interface and the VLAN if and loopback zeros. And after finishing it, I think we need to check the connectivities on the border device. We need to use the ping command to check if the border can communication with the edge switches. It should be this one, and it should be this IP address. Oh, wait a moment. Choose request out. Oh, wait a moment. For this, oh no, it should be this IP address. Wait a moment. Why it can communication 12. Wait a moment. 12. For the board device, okay, they can communication with the two edge switches. And what is next? Next is we need to configure the OSPF to finish the IGP configurations. All right, and the configurations will be the simplest. Just configure all the interface into the area zeros and configure the root IDs, and I will finish this config. First, let's configure the H1, this switches, configure H1. And then we need to configure it should be the border switcher. For the board switch, we configure the OSPF, and then at last we configure the H2 this switch. All right, configure the H2 the switches, and now I think we just need to wait. All the OSPF is full state. Just wait a moment. Let's check it. OSPF peer brief. And now they are at the true state. And wait a moment. Just wait. They are into the full state. Okay. Wait a moment. Okay. Now the OSPF peer relationship between the 2D switches and the borders, they all meet, they are under the full status. And now maybe we can just try to check if the H1 can come, the H1 for the H1 for the H1 and H2 we need to establish VXLAN tunnels. All right, and we will use the interface look like zero is IP address to function as NV is source IP address. So the loopback zero interface should communication with each other. Now let's just check it. Maybe we can check it on H1. And you should remember that what is IP address of interface zero? It be this. So we just need to check it. And we need to specify the source address, and the destination IP address should be the H2s. And you find that for the H1 and H2s, they look like zero can communication with each other. So what is next? The next is we need to finish the VP access configurations or the service access point configurations. Now for the edge switches, we need to create the bridge domain and bind the VXLAN WinRs for the bridge domains, and then we need to configure. The level 2 sub interface to use the level 2 sub interface to accept the traffic from access switches, and it is same for the H2s. And what is next? Next, for the access switches, you should know that for the access switches, the interface that connected to PC, we should configure the interface to access port. And for the interface connected to the edge switches, we need to configure the interface to the trunk mode, all right? And we need to allow the VLAN path. All right, now let's finish these configurations about access point. The first is it should be the H1. Wait a moment, let's check it. For the H1, you shall find that the first thing is we need to create a bridge domains, and inside the bridge domains we need to configure the VXLAN WinR IDs, and then we need to configure. I think this part is most important. We need to create a sub interface of this interface. This interface is used to connect to access switches, and we need to use this interface to terminal the VLAN tag, and then we need to bind the interface into the bridge domain. All right, and now we finish the configurations about the H1. Next is the configurations about the H2. Will be similar, or just the same. You will find that. Now let's configure the H2. We created the bridge domain. We bind the VXLAN WinR into the bridge domains. We configure the sub interface to accept the traffic from the access switcher, and then it is configurations about the access switches. It is simple. Create the VLAN and configure the interface that are connected to PC. We configure it to access mode, and set its default VLAN to 100, and then set the interface that are connected to edge switch to twin mode and permit the VLAN to pass. That is all the configuration. All right, now let's configure it. We need to create the VLAN on the access switch. And okay, and for access 2, we need to do the similar things, but just the different things is the physical interface that are connected to the terminal. It is different from the access 1, and other things is the same. Now we have already finished the VP configurations, and then it is the VXLAN tunnel configurations. We need to create the NV interface on the edge 1 and edge 2s, and you will find that we use the source address, and this source address is the IP address of the loopback 0, and we need to configure the hand and PR list, or it is a replication list, and you will find that the VXLAN tunnel is configured manually. And now let's configure it on edge 1. On the edge 1, we configure the interface NVE and configure the source IP address and the hand and peer list. For the edge 2, we configure the similar things. Now we have already finished it. Now let's check it. Maybe we can check the VXLAN tunnel status on the 2 edge switches. All right, now let's just check it. For the edge 1, display VXLAN tunnel to check if the tunnel is up. You will find that it is the up status, and you will find that we only have the source address, destination address, and then let's check the VXLAN peer. You will find that we have a static VXLAN peers, and in the peer, we will have the winner IDs. And for the edge 2, it is the same, display VXLAN peer. In the VXLAN peer, we will find we have the source and the destinations and the winner IDs. So you will find that we have the VXLAN tunnel and the VXLAN peer. They are the different things. Inside the VXLAN tunnels, we don't have the information about the winner IDs, but for the VXLAN peer, we have it. So what it means? It means for one VXLAN tunnel, so we can carry the traffic with different winner IDs. So you can just find that it's like the GRE, right? Maybe we just have one GRE tunnels, but we can just use it to carry different traffic. Okay, now let's just to verify the result. We have 2 terminals, and the 2 terminals we need to configure its IP address manually. All right, now I need to I need to log into the 2 terminals, PC1 and PC1 and PC2. Wait a moment, PC1 and PC2. Now I have already logged in the PC1 and PC2, and for the PC, wait a moment. For the PC1, wait a moment. Oh, wait a moment. For the PC2, I need to check its IP address. IP config. You find that for the PC2, its IP address is not this IP address, just because I used it for other aims, so I need to configure it IP address manually. And by the experiment is design, the PC2 its IP address should be this, right? I need to configure it. And then we need to configure the IP address of the PC1. And you find that we still need to configure its IP address. And then just let verify if PC1 can communication with the PC2. And I use the ipconfig command to see what is the MAC address of the PC1. And you will find that for this sorry, for this network adapter, its MAC address is this, and this is its IP address. And for PC2, I think I need to check it. All right, for this IP address, for this network adapter, so you just need to remember the suffix of the MAC address. The suffix is the E3, and for PC1, it is the EA. So now just check if they can communication with each others. Wait a moment. Maybe I need to check my configurations about the device. Wait a moment. For the access, I need to check it. For the LDP neighbor brief, age, it is age switches, access switches, port. For the age one, the bridge domain have already been used a global. Yes, I need to undo it. Undo VLAN 100. Okay, now we need to configure it, the AG2, just because you can't use the, if you want to configure the terminal, the sub interface to terminal the VLAN, and you can't create the VLAN ID globally, so that it is why it fails. Now let's check it again. For the PC1, wait a moment, I need to check it if it configure successfully. Yes, it configured successfully. And for the H1, spray MAC address bridge domain. And I think they have already learned the MAC address. And so what is the problem? Maybe it is a firewall. I think it is the firewall's result. Maybe I need to disable the firewall on PC2. I don't know why, but you can find that for the PC2, it can communication with PC1, but the PC1 can communication with the PC2. Oh no, I don't know why. Just a pin to the best. Just like check it why the result would be like this. Oh, wait a moment. Let me check the router tables about these routers. That makes sense. And I think they share communication with each other. And wait a moment, you will find that. Wait a moment. one. No, it doesn't have the ARP informations. That's not right. You can find that for the PC1, it have already learned the ARP informations about the PC2, and I think the result will be the same for the PC2. It should have the ARP informations about the PC1s, but just the PC1 kind of communication with the PC2. I think that is PC's problem. Let's check it. Use this. That is weird. Maybe I need to check the routing table on the PC2. What is the root? Okay, it doesn't matter. I think it is problems of the terminals. And I need to check if the packet have result by the PC2. No, it doesn't have. So now the West handles have already can let PC1 and PC2 communication with each other. But no, now I just check it. What is the problem for the interface? And I don't know why. Maybe it is problems of my setting. Wait a moment. I need to check it. Try. Yes, I think you're right. And I think maybe his problem. It should be the compete. Yes, I think you're right. And maybe there's problems. Wait a moment. We believe it should be 10. So I find that it is the communication, but I don't know why PC1 is problem. What is problem with PC1? Wait a moment. I need to check it. For the PC1. And I think they can communication with the PC2. Oh, wait a moment. It doesn't. Oh, wait a moment. I need to think. Maybe it is a NVIDIA interface problem. It can't communication with it. That's not right. They can't communication with the PC2, but PC2 AD switches. PC2 can communication with the PC1. That is the problem. For the PC2, it can communication with the PC1, and they can learn the ARP informations. All right. If you try to, you'll find it can communication with the PC1 and can communication with the AD switcher. But if you try to another direction, it can't. So maybe I need to check it is the configurations about VXLAN. Wait a moment, I need to check it on the mode. For the NV interface, bridge domain. Wait a moment, what is NV interface? Where is NV interface? Interface NVE. So the choice, I think maybe it is a problem just because you can find that if we try to from the PC1, from the PC2 to the AG1 and to the PC1, we can communication. But if we do a reserve communication, it can't. I need to check where is the problem. No, NVE interface. interface relief NVE interface. And if you try to check the MAC address run tables, and you will find that they have already learned the traffic. So the problem, I think, maybe, I don't know why it is the terminal's problem for the PC2. And I think it is not the problem of the VXLAN and app configurations. And I think it is problems about the PC2. And I need to check it if I didn't disable the firewall. Yes, you can find that. I think it is problem of the firewall, just because I have one firewall didn't disable. You can find that. So you can find that it's problems of the PC2's firewall. And then maybe I have already disabled it, but for another type of the network, it open it. Okay, now it is the static VXLAN tunnels, and you will find that how do we finish our experiment, and how the VXLAN finishes the communication between the intra subnet. It is just by use the VXLAN tunnels, and you will find that for the MAC address tables, it will be a little different. The length form can be another IP address, can be another V type. It not must be the physical IP address. You can just think VXLAN is an extension of the VLAN, and they can build virtual broadcast domains between different switches. And now we need to do another experiment. This experiment it is centralized VXLAN gateways, and you will find that the experiment will be little different. The different configurations is on the borders. We'll use the border to function as the centralized gateway. So we need to configure VBDF on the border, and we need to configure the VXLAN tunnel between edge and the border switches. But for other configurations, at least for the edge 1 and for access 1, we don't change the configurations. But for the edge 2 and access 2, we need to configure another broadcast domain, and we need to change the PC2 IP address. So now let's configure it one by one. And for the access point for the edge 2, all right, for the edge 2, we need to configure the broadcast domain. Oh, it should be centralized gateway on this place. On the edge 2, we need to create bridge domain 20s, and we can configure the interface. All right, now let's configure it. We just need to change a little config. First, we need to configure the bridge domain, and on the edge 2, bridge domain 20s, and then we need to configure the another sub interface. Or we need to configure another sub interface. And then for the access 2, we need to change the trunk port. For the access switch 2, you need to change the access VLAN to 200. And for the up interface, you need to add a new VLAN to pass. So now let's check it and configure it. For access switch 2, okay, now you will find that we already changed the access VLAN for the PC2, and we add a new VLAN that can pass the uplink. And then we need to configure what? We need to configure the NV interface. You find that now we need to configure the VXLAN tunnel between border and edge, not the two edge, not between the two edge. The first things we need to configure the configurations about the edge 1. For the edge 1, now you will find that the hand and peer list, the peer is another edge, but for now we need to change it. we need to pair it to the border. And for the border, we need to create the corresponding configurations. For the border, we need to create the bridge domain, and we need to create the VXLAN handles. And for the H2, we need to change the configurations as well. For the H2, we need to change it NV configurations. We need to change its pair to border. And then on the border, we need to configure another bridge domains and another NVE interface configurations. For the border, we need to create the bridge domain 20s, and we need to configure the NV interface to add a new NV WinR values. Now you can find that on the border, so we have two VXLAN tunnel. Now let's just check it. Now on the border, let's check the VXLAN tunnel and pair. The two tunnels is up, and we have two pairs. Different pair have the different WinR IDs. And then what is next? Next, we need to configure the VBD on the border. But first, we need to add an additional configurations on H2. All right, interface VBD. And then we can configure it on the borders. We need to configure VBD10 and VBD20 on the borders, and the two interface will function as the gateway of PC1 and PC2 respectively. But now we need to change the IP address of PC2. We need to change its subnet, change it to another different subnet, and it should be the 2, and we need to configure its gateway. And for the PC1, we do the same things. No. We need to configure its gateway. The first thing is, let's check if they can communication with each other. Wait a moment. Wait a moment. First, they can communication with the gateway. For the PC1, they can communication with its gateway, and for the PC2, let's check it. Oh no. I need to check out my configurations. And I need to check it on the access to switch, and on the H2, on the H2. On the border, on the H2. For this interface, and for this interface, the configuration is right, and we need to check it. For the access 2, the VLAN should already set be 200, and for the upper layer is right. Let's check it for the H2. Peer list 100. No, this configuration is not right. All right, it should be NVR 2000 and peer list. Now let's check it on the PC2. Okay, now it can communication with the gateways. Now PC1 and PC2 can communication with the gateway. Now just check if the using table is right. The using table, for example, now let's check if PC1 can communication with the PC2. You can find that PC2 can communicate with the PC1, and I think is the same result for PC1. You can find that they can communicate with each other. But now, just let's check what is the process of the forwarding. First, PC1 should be awareness that the destination IP address about this, it is not in the same subnet. So it will try to find its gateways. All right, its gateway is there's 100.254. And it will try to use the AIP request to get its the gateway's MAC address, and it will find that it will end with the FV, and we can check it on the border. We can display IP interface VBDIF, and you will find it. It is this interface, and but you can't find, and you can see it is a MAC address, and for the this interface, it is same. And for the AG1, you can find that for the AG1 will try to forward the traffic that to designated for the VBDF10. You can just find that. So when PC1 try to communication with PC2, the packet will send to the AG1, and AG1 receive it and just search the MAC address table and just follow this entries. It will send the packet to border, and the border receive it. After border receive it, what it will do? Border receive it. You will find it will check its bridge domain. All right, MAC address entries. You'll find that the destination MAC address about the frame, it is sent to itself. So for the border, it will try to looking for the routing tables. So what is the result of the routing table? You will find that it will find a direct router. So it will try to check the AIP entries and the MAC address tables. And I think it will find AIP entries that match the destination IP address, and then it will try to find the MAC address table on inside the bridge domain 20, and you will find that that is the destination. So what is the next hop, or which place it learned from? Is learned from another VType, and this VType is AG2. And for the AG2, when it receives a frame that's sent by the border, it will try to check its IP address. It is it checks the destination MAC address, and it will find that the destination MAC address is learned from itself, and then it will send the packet to access. All right, that is how the centralized VXLAN gateway to let different terminal belong to different VXLAN segment can communication with each other. It is not difficulties, but now we will do the distribute VXLAN gateways. So now just find what is different. The different things, the borders it will don't have the VBDF. We will create the VBDF on AG1 and AG2, and for the AG1, it have a PC1 connected to it, and for the AG2, it have the PC2 connected to it, and for the AG2, we will have another VLAN if on the access2, we will create a VLAN if 100 just to simulate the terminal that belongs to the same subnet with the PC1, and we will use the BGP European protocols. So now let's look at what is different things, and I think for the basic configurations it is the same, and but things will be different. First, for the AG1, the configuration is still the same, but For the AG2, we will create the two broadcast domain, bridge domains, and I think we have already finished it. All right. On the AG2, we need to create a bridge domain 10 and 20, and I think we have already finished it. All right, we have already finished it. And for this port, for the downlink, we need to create a two sub-interface, and also I think we have already finished it. All right, we can just check it for the IP for the interface brief. We can see that we have already created two sub-interface. All right, and what is next? The next is on the access switch. On the switch 1, we need to create two. Oh no, and I think for the access switch 1, we don't need to configure two VLANs. But for the access switch 2, we need to create a two VLAN. And I think also we also already finished it. Display VLAN, we have already created VLAN 100 and 200. And for the uplink, for now, for the uplink, we need to create this link to allow paths VLAN 100 and 200. And now we have already finished it. You'll find that we have already finished it. But the different things is we need to create a VLAN if 100 and configure its IP address to 100.2 to simulate another terminal. And then we need to create another static routers. And its next hop will be the VBDIF IP address. And then what is next? The next is on the AG1 and AG2, we need to change the configurations about the NVE. So now let's check it how to configure it. On the AG1, we need to configure the protocol to BGP, not the static peer list. For the we need to undo it. And then we need to configure the hand and peer list, the protocol to BGP. And for the AG2, the configuration will be the same. And what's next? Next, we need to configure the VBDIF 10 and 20 on the AG1 and AG2. So now let's configure it. The bridge domain exist. Oh, and I think before it, we need to create the broadcast domain on the AG1. And for the AG2, the configuration will be the same. Okay, and you should notice that for the interface, we configure this command. We configure its MAC address. For AG1 and AG2, we configure the interface with the same MAC address, and then we enable these features, ARB collect host enabled, so that the ARP address can generate the BGP European router. All right, and on the border, and I think we need to undo the VBDIF. And we need to undo the NV interface just because we don't need to use it. And then what is next? The next is we need to configure a UP instance and IP UP instance. And what is their functions? And I think I have already introduced it before. So we have a design, and we just to configure the UEP instance and the IP routing instance by our design, by our plan. So the first thing is when you configure it on the edge one, for the edge one, when you configure the UEP instance and bind it to the corresponding bridge domain. For the edge two, the configuration will be the same, but the RT values is different. You should notice that. And what is next? The next is if the VBDIV10 and PIV20, if they want a communication with each other, it means they should bind to the same IP VP instance. So on the edge one and the edge two, the VP instance, the RT values, it should be the same. You will find that. So now let's check it. We can find that on the edge one, when you configure the IP VP instance, all right, and we need to bind it to VBDIV interface. And VBDIV10 and VBDIV20 is. But what is next issue is that if we bind IP interface with VP instance, all the IP configurations will be removed. So we need to configure the IP address again. First, on the edge one, we need to bind the VP instance to the VBDIV, and then we need to reconfigure the VBDIV with IP address. All right. And for the edge two, we need to the configuration will be the same. First thing is for the edge two, we need to configure the IP VP instance, and then we need to bind the IP VP instance to the corresponding VBDIV, and then the next is reconfigure the IP address of VBDIV. What is next? The next is we need to configure the BGP UAPN, and the configure will not be very complex, just because we don't use RR, we just let H1 and H2 establish BGP UAPN pairs with each other directly. So the first thing is on the H2, we configure the BGP UAPN. And let's look at what is the configurations. The first, we need to configure the BGP ES, and we use the interface loopback 0 IP address to function as root IDs, and then we need to designate the peer address. And the last one and the most important one is we need to enable the peer relationship inside the level 2 VPN family, and we need to use this command to let we will set the IP routers to its peers, and also inside the IPv4 VPN family, so we also need to use this command. We see that by using this command, we can advantage the routers to VPN peer. And for the H2, we need to do the same configurations. Okay, now for the H2. Now we have already finished the configurations about the distributed gateway. And now let's check it. What we need to check? We need to check the BGP UAPN peer if they have already. Wait a moment, display BGP UAPN peer. Now it is active state. Wait a moment. Okay, now they have already entered the established status. Now the H1 and H2, they have already established the BGP UAPN peers. And what is the next? Next is we need to let the BGP UAPN can generate routers, water routers, the RRP routers. So the first thing is now that we need to use the terminal to ping its gateways. For example, for the PC1 to ping its gateway. Okay, now it can communication with gateways. So we shall know that for what is the which gateway is the most close to the PC1? It should be the VBD10 on the H1. All right, so we can check the AIP address. You can find that. Now for the AIP address, we can find we have already learned the AIP address about the PC1, and let's check it. And you can find that the AIP address have a which question, please? So which questions about it? So can you hear me? Which questions about the nope. Maybe just because my microphone is not closer to my mouth. Okay. The first thing is now the PC1 shared communication with its gateways, and which gateway is the most close to PC1? It should be the VBD on the H1, all right? And for the H1, we know that we have the VBD 10s. And now let's check the AIP entry on the H1. And you can find that we have the AIP entries on the H1, and you can find that the AIP entries have a VP instance. This VP instance is bound to VBD 10, okay? And now I need to check the BGP European router. You can find that. Now you can find that for the H1, it have already generated type 2 routers, and you can find that it should be the RB type routers, just because for these routers you can find the MAC address and also the IP address, and maybe you will see that maybe it is the AIP routers, but we can check it. We can check it the router verbose information. You can find that if the router have 2 MPLS label, it will be a RB router. But if it only have 1 MPLS label, it will be the AIP router, right? And you can find that it have two MPLS labels, or the WinR. One is the level 2 WinR, and another is the level 3 WinR information. And this WinR 1000, you can show that just because the traffic is received from the BD10, so it will have the level 2 WinR information. And this, you can find that it is should be, wait a moment. You find that inside the VP instance that bind to VBD, we configure the VXLAN WinRs. Just it is like the MPLS labels to tell H2 which the router is which VP instance the router belongs to. So you can check it if the H2 have already received the router that sent from H1. Now you can find that for the H2, it have already received the type 2 router, all right, these routers. And what is next? The next is it have already a routing table, all right, and it is a host router. You can try to check its IP routing table. H2. You can find that for the inside its IP routing tables, it have a host routers, and its next hop is the H1. So what it means? It means if the AJ2 receive a packet and its IP address and its destination IP address is about this, it will not match the direct route. It will match the host routers and send it to the AJ1. And now let's try to configure the IP address. Let's use PCA2 to ping its gateway. You can communication with the gateways. And another question is, which gateway is the most close to the PCA2? It should be the VBD if 20 on the AJ2, all right? So you can find that if the AJ2 have the AIP address about the PCA2, you can find that it has the AIP address about the PCA2, and it have a VP instance attribute. And if the PCA2, the AJ2 generate BGP UEP route about this AIP address, let's check it. Now you can find that for itself, for the AJ2, it have already generated BGP UEP type 2 routers, and you can check it verbal information. You will find that it also have two MPLS labels of the WinR information. The first is the level 2 WinR, and another is the level 3 WinR information. And let's check it on the AJ2. We can just check its IP routing table. And you will find that now for the AJ2, it also have the host routers to the PCA2. And now let's try on the PCA2. We can try to ping its gateway. And for the access tool, which one is the closest gateway for the access tool? It is the VBD for 10 on the AJ2, all right? And so now let's check it, the AIP entry. You can find that for the AJ2, it have already AIP entries about the VLAN if on access tool. And if, let's check it, the BGP UEP routing table. You can find that we have BGP UEP routers about the AIP entries. And now I think for the AJ2, it have already have the routing, the host router to the VBD, the VLAN if on the access tool. So now let's check how the communication with each other. So let's check if PC1 can communication with PC2. You can find that now PC1 can communication with the PC2. And what is the forwarding process? The first thing is the PC1 will try to send the packet to its gateway, all right? And which is the gateway? Its gateway should be, you can just try to check the, you can find that what is the gateway about the PC1. You will find that is the gateway about the PC1. And the AJ1 will receive the packet that sent by the PC1, and you shall find that AJ1 will try to check its IP routing tables, and you shall know that the interface that received the packet sent by the PC1, this interface have already banned IP VP instance. So for AJ1, it will try to check the IP routing table inside the VP instance. What is the result? The result is a host routers. And this router, it have a nest hop. And if you try to say the verbal information about these routers, you will find that it have a level 3 WinR information. And the level 3 information is bind to IP VP instance, all right? And for AJ2, you can check the IP VP instance. And this packet will be received by AJ2. And edge to receive it, and it will check the WinR information that carried by the packet. And what is the WinR IDs? It should be it should be 1020, all right? Just because for the edge one, for this IBGP, and I think maybe we can say it's verbose information. You can find that its interface is VXLAN and its label is this, all right? It is the WinR informations. And edge to receive it, it will try to find which WIP instance can match the WinR information. And it will find this WIP instance. So, and it will find that the destination MAC address is itself. So it will try to search the IP routing table inside this WIP instance. And what is the result? The result should be a direct router. All right, should be a direct router. It should be this direct router, and then it will try to search the AIP address. And the first, it will try to search the AIP address. It will find the AIP address, and then it will try to check the MAC address table, and it will find the MAC address address, and it will send this packet to access2, and access2 will send it to the PC2. So you will find that if we use the distributed gateways, you will find that most of the time for the V type, it just forward the packet by the host routers, and we don't need to use the broadcast domain between the V type. So that is the VXLAN distributed gateway. And I don't know if you have any questions about this part. Okay, and I don't. Can I can I ask a question, sir? I don't know if you will use the VXLAN technologies in your training lessons, or if you have working experience about VXLAN. Okay, and I think if it is only in labs, and I think it's okay, just because you will find that for our DITCOM lessons, and you should know that in the traditional IS, I mean the auto vision, in the IS, and the IS examination will not test the VXLAN, and it is more concerned about the routing protocols. All right, and but now you'll find that the next experiment is also the utilize the VXLAN campus deployment. We use the controller. So I think if you have the VXLAN, if not experiment, but if you know you are familiar with the VXLAN, it's okay. And maybe you will just will find that in after the DITCOM release, maybe you will pay more attention and consider more about VXLAN. And maybe you need to teach your student what is VXLAN and what is distributed gateways, and how to deploy it by use our controller. So maybe you need to change your mind about our certification. It is not and the only things I can tell you is it will not be the different. It will not be the same like the routing switches. You shall know that for the routing and switches, the UVPN, SIS, OSPF, those things will occupy a very high percentage, but now it will not. And you can find that for the lab guide. For the lab guide, you can see the MPLS, the interdomain, all right? You can find the BGP, large scale BGP, and you can find the large scale SIS. The more, you can just look at the lab guide, what is designed as a lab guide, and I think you can think the answer by yourself. The answer is, the only thing I can tell you, it will not be the same compared to the routing and switch. And I think all the things that have already written in the lab guide you should pay more attention to it, but not the traditional routing and switch.